This video introduces time travel analysis, a powerful feature in eShard's esReverse platform, designed for in-depth security analysis of binary files. Time travel analysis enables you to record and replay the behavior of software or systems under investigation. In this demonstration, we've recorded a complete Windows system, capturing a specific moment where a bug causes the system to crash. This bug, linked to the Windows relocation mechanism during the parsing of a PE file, corresponds to the CVE 2019-1347 vulnerability. Now, let's explore the esReverse graphical interface, which allows us to navigate through the recorded trace of this bug. We can precisely review the recorded execution by displaying the frame buffer, which reproduces the screen output based on the captured video memory. Using the timeline at the bottom of the screen, we can replay the execution up to the appearance of the classic Windows blue screen. One of the standout benefits of time travel is the ability to navigate forwards and backwards through the recorded execution. The esReverse platform provides a range of powerful features to support this. For instance, the search feature allows us to locate specific API calls, such as keybug check, which is triggered during a system crash, and return directly to that point in the execution. The center of the interface displays the execution trace, showing each instruction the processor executed. We can easily step back or forward to analyze the flow of operations. A call tree representation is also available, allowing quick access to significant execution points. For example, here, we can jump directly to the memcpy function that generated the crash. At any point during the recorded execution, we can view the state of all CPU registers and inspect memory content. Additionally, using the memory address operation history, we can track how data changed over time and instantly locate the operations that read from or wrote to a specific memory location. The platform also offers a wide range of navigation options, such as data flow tainting. You can filter the trace to focus on specific processes or user land sections, further refining the analysis. While this demonstration shows time travel analysis on a Windows system, esReverse also supports Linux and Android platforms on Intel x86, x64, and ARM architectures, providing flexibility for a range of security research environments.